Welcome to this short exploration of blockchain essentials. In the next few minutes, we'll unpack what blockchain is, why it matters, and the key characteristics that make it a powerful tool for secure, transparent record keeping. Think of this as a guided tour that will give you the intuition behind the technology without getting lost in technical jargon. This slide shows how blockchain groups transactions into blocks, links them cryptographically, and forms an immutable ledger. Imagine transactions being batched, each batch producing a unique hash that references the previous batch, so any change would break the chain. The diagram on screen highlights aggregation, hashing, and the resulting tamper-evident ledger that preserves data integrity over time. Not all blockchains are the same, and this slide contrasts public and private designs. Public chains let anyone join and validate, offering openness and wide decentralization like Bitcoin, while private chains restrict participation for faster consensus and enterprise confidentiality. The choice depends on your use case. Pick openness and transparency for public networks, or efficiency and control for private, permissioned environments. Here we focus on immutability and why altering past records is effectively infeasible. Once a block is validated and sealed, changing it would require rewriting all subsequent blocks and convincing a majority of nodes, which the graphic shows as prohibitively expensive and easily detectable. That chained protection is what makes fraud attempts visible and preserves a trustworthy history across the network. Decentralization spreads control across many distributed nodes rather than one central server, and that has practical security benefits. Collective validation removes single points of failure, reduces censorship risks, and lets users hold custody of their assets without intermediaries. The visual of interconnected nodes emphasizes how resilience and shared responsibility replace centralized control in a blockchain system. Two core characteristics often work together: full auditability and enhanced privacy. Because each node can see transaction histories, the network supports complete audit trails and accountability, while cryptographic addresses protect individual identities and secure interactions. This combination enables transparent verification across participants, while preserving privacy and deterring fraud through strong cryptographic safeguards. Consensus protocols are the rules that let a distributed network agree on which transactions are valid. Whether through energy-intensive proof of work or stake-based proof of stake, these mechanisms aim for supermajority agreement, prevent double spending, and ensure only valid blocks update the immutable ledger. The flow diagram shows how proposals become validated blocks through consensus and then become permanent records. The security of blockchain rests on three core principles: digital signatures that authenticate transaction origin, hash functions that create unique fingerprints for data, and public-private key pairs that secure wallets and access. Together, these tools verify ownership, detect tampering instantly, and enable users to control funds securely, producing immutability and robust protection across a decentralized network at scale. Smart contracts automate trust by embedding self-executing code on the blockchain that triggers when predefined conditions are met. These scripts enforce agreement terms without human intermediaries, enabling use cases like trustless escrow, token issuance, and decentralized applications. By turning legal or business logic into enforceable code, smart contracts open up secure, automated processes and new business models. Finally, blockchain finds practical applications across industries and delivers clear benefits. Use cases include cross-border payments and supply chain provenance, digital identity management, and decentralized finance, and the impact shows up as lower costs through automation, increased accountability via shared ledgers, and industry transformation through verifiable, tamper-proof records that reshape how trust is established and maintained.